Okay, so today finally try to completely about the bipolar transistor. This part we will be talking about the amplifier. You understand, you get the two parts, okay? One for DC bias. That means they need the DC for the transistor to work, okay? However, they need main thing will be amplifier. And we get the three different amplifiers. First thing will be a common emitter amplifier. Second thing will be a common collector and common base. Okay, today a little more advanced in detail about the AC amplifier. Okay, only thing is for most of the technicians, when you're looking into the circuitry, you're able to identify what amplifier, CE or CC or CB, okay? And also what happened to the input and the output, okay? So now the first one will be a common emitter. Input will be applied to the base. Output will be from collector. And the input and output will be opposite. Or we can say they will be 180 degrees of phase. Okay, that is a basic thing for any technician need to know. Also, second thing, they want to know about the capacitor. What is the name of its capacitor and what they doing? Okay, so the first one, C1, that will be DC locking or AC coupling. That means they allow the AC from the source go to the base, but not the DC. And the C2 also DC blocking and AC coupling. That means they not allow any DC voltage from the collector go to the load. The load like the speaker, okay? The speaker, they don't want any DC, just AC. And the last capacitor C3, that will be called bypass capacitor, okay? Bypass what? They will bypass any AC current go to RE. Yeah, you get a question?
No.
C2 is bypass.
I think you got the numbers mixed up on the capacitor.
Yeah, it's C2 that is the bypass capacitor. C3 is
Oh,
the
that's okay.
coupler.
C3, that means in this case, they will be bypass, no, DC blocking. And C2, a bypass. The thing I did, I get from the textbook, okay? So that doesn't matter. You see it, you know which one is bypass or which one will be DC blocking.
Yeah, I have one question.
Yeah, go ahead.
On the top, it is written beta DC is 150 and beta AC is 160. So beta is a current gain.
Yeah,
So-
that's the current gain for
So
either DC
is the
or
trans
AC.
is going to gain DC also and AC also. You said that capacitor will not allow, C1 will not allow DC. It will only allow AC.
No,
Then
no,
how?
that's okay. Normally, they can using only beta for DC, either AC circuitry.
Okay, go ahead.
Okay, that doesn't matter.
Okay, go ahead.
Okay, now, if we're looking into the circuitry, and you can see you get a sine wave coming in at the base. So you can see at the base here, okay, you can get a DC voltage and AC voltage, okay? However, at the emitter here, you only get a DC voltage, but not AC. If you measure AC voltage here, you get 0, okay? I given you example. You get a sine wave coming in, okay? 20 millivolt. Then at the base, you get 20 millivolt. However, at meter, you get 0. The thing is you get a bypass capacitor. They short the AC to the ground, okay? And at the collector here, you will be get also DC and AC, okay? The thing is you still get a DC voltage for collector, okay? And at the V out, only thing you get will be AC. That in general, when you're looking into the picture, at least for technician, you need to memorize those. And then we can go into the AC analysis. You understand that when you're converting the DC to the AC, then you not see any more capacitor. The thing is capacitor in AC, they just like the wire. Okay, so that's why. And you cannot see any DC voltage. DC must be routed. Okay, that is the rules. And also you can see the transistor in the AC, they will be different. Not look like the transistor you see it now. Okay, and now you can see on this one, they still keep the capacitor, okay, but they draw for you. R1, R2, now they will be connect to the base and connect to the route. You know why? The thing is on VCC, they sort it to route. So that's why R1 also one side connect to the base, the other side to the route. Okay, and also at the collector here, you can get RC, connect to the route. The thing is, one side of the RC connect to the VCC, and the VCC connect to the route. Okay, and now you go to the second one. This part here. Okay, you can see the dark part right here. That will be generator. And when you're looking into the amplifier, you get a resistance. That's what normally they call a G in, input impedance. That means if you're looking into the amplifier to see how much resistance you get, okay? And then Also, if you're looking into the output, okay, this one right here, that's what they call an output resistance. So deal with the AC. What we need to know. We need to know what the input resistance, what is the output resistance, and also we want to know the gate. Okay. Any question on this slide here? No.
Hey, Mr.
Now,
Payne,
yes, sir.
uh, I was trying to unmute my mic while I was, that last one you did, maybe you can even explain it with this one, but the two resistors, R1 and R2, they're in parallel.
Right.
So what are their functions again? R1 and R2? Because they're in parallel?
Now, R1, R2. Okay. You see on that one, right?
Yeah, but you said that this one was,
No. Hold on. When you converting to AC,
right,
it must be round.
right.
So this round R1 connect to the base and connect to the round, so they will be parallel with R2.
Right.
So that's why they draw for you this one.
Okay. Hey, the first drawing, but I understand what you're saying because you first taught us about biasing for DC, and then now you're talking about biasing for AC. Is that correct?
AC, not bias,
Okay.
only DC. Right
Okay.
now, we're doing for AC only.
Okay. But the term bias don't go in there.
Now,
Okay.
bias, that means the transistor needs a power, DC power
Okay.
to work it.
All right.
Yes. By the way, Mr. White, what main of the R1 or R2 used for? What main we?
No. That they must be here. Why? You understand why R1, R2 using here? Okay, I repeat it. For bias, the transistor, they need either they can using two power supply, or they can using one power supply. In the past, you're using VCC, VBB. Okay? So instead using second power supply, they don't want it. They just using two resistors to get a voltage divider. So that's why you can get a voltage at the base. Okay? Without another power supply.
Okay.
Yeah.
R1, R2, 25 cents. For X must be cheaper than another power supply. So that's
Yeah.
why this configuration using all the time. Okay?
Okay.
So
Okay.
when I change to the AC, then R1, R2 must be parallel. The thing is DC power connect to the ground.
Yeah, I see. Thank you.
Yeah, no problem. Okay, so now on this one here, second one, we're talking about two things. Input resistance, output resistance. Input resistance, that means you from the source here, you're looking into the transistor. How much resistance you get, that's what they call input impedance. Okay, or some different book, they say input resistance, that doesn't matter. And the one connect looking into the output, that's what they call output resistance. Now, this is a little more detail. Okay, so now you can see We don't care about RF right now, okay? They will be a output impedance for the generator. Only we care will be here. So you see R1, R2 parallel. However, also you can get the resistance from the base to the ground. That's what they call a R in base. So basically you get 3 resistors in parallel. And now go to the second one. You can see they can combine everything. R1 parallel, R2 parallel, R in base into one they call a R in total or G in, either way you want to go. Okay, so in order to calculate the input impedance for the CE amplifier, you take R1 parallel, R2 parallel with R in base. And we'll be doing calculation R in base for you to see it. Only thing is for AC, you deal with input impedance, output impedance, and the gate. Any question, just stop me, okay? We don't get back to this thing no more. This
Mr. Pham,
advanced high, advanced engineering.
I have a question, Mr. Pham. So,
Yeah,
are we going to consider RS with the R total as total of RN?
when you're looking into the amplifier, they calculate for you the total resistance, right?
Yes.
And total will be here. R1 parallel R2 parallel R in base. That means from the base to the ground, you can get the resistance. That's what they call R in base. And those 3 resistors in parallel. Okay, so they given you the total impedance or resistance they call a R in total. I call a G in total impedance, same way. Either way you want to say. That means they combine R1 parallel, R2 parallel, R in base into one resistor. Formula how to do calculation.
Yes, and for the RS, we disregard it because it's very small. It's the source resistor.
What
Is this the
are
case?
RF?
Yes.
Don't worry about that. That's an inside generator.
Oh, okay. So, and
Okay.
I think it's very small, so we disregard it.
Yeah.
Okay.
Mr. Pham,
In the source resistance.
Mr. Pham,
Yeah.
is the R1 parallel, R2 parallel, RN base parallel formulated like resistance in parallel? Do you use the same formula?
Exactly.
Okay, 1 over RT. Over.
Right. Exactly.
Got it. Thank you.
Now we go a little more. So now you can see the first one, you don't see any more transistor. They said transistor will be substituted by this one here. Okay, that means from collector you get the current flowing, and that current will be equal beta IB. We already know that IC equal beta IB. Okay, when they go into the base, from the base to the ammeter, Also, you get a small resistance R prime E. Okay, so this is inside the transistor. Okay, and you know R prime E equal what? The formula equal 25 millivolt divide
IE.
okay,
E.
divide by IE.
Hey, Mr. Pham, I hate to interrupt, but earlier one of the students asked about the betas. You had a DC beta and you had an AC beta. That obviously the DC beta was for the one where you did the biasing, and this AC beta is for this one only, correct?
DC bias.
Yeah, right. That's what I meant. But this one here is beta AC.
Yeah, that's for AC. We don't have any more DC here.
Right. Okay, thanks.
Okay, now you can see that the difference between, okay, between the transistor in the bias DC. So basically, you can see that one here. Base, collector, emitter. And you understand we still get the current IC go here. Beta IB. The current flowing here, IE. Okay. However, you can see the difference. The difference is you don't see any diode here. This is the diode from the base to the emitter. And now they change into R prime E. So you don't have any diode in AC module. That's a very important thing. The interview they asking you. Any question on that?
Can you explain one more time? I didn't follow
Oh,
regarding the diode.
what I'm saying here, this is a transistor in DC, and this is a transistor in AC. In the AC, they not draw the transistor like normal. They just draw one current source go to the base, and one resistor R prime E go to the emitter. You understand R prime E is the internal resistance. That means the resistance inside the transistor.
Okay, go ahead. Thank you.
Yes, if you want to deal with the AC analogy, instead you draw the transistor this way, you must be drawn this way. That is the most. Okay. Now, first thing you can see, how do they calculate the R in base? If you want to calculate the R B in general formula, can you tell me? Law, what are B?
VB or IB?
Exactly. VB by to IB. So that's why in here, see here, they say, okay, R in B equal VB divide IB. Okay. And VB, that means from here. Right? VB means from the base to the route. And that VB will be equal. You get resistance R prime E and the current flowing here IE. So that's why you can see VB equal IE times R prime E. Now what IB equal? IB equal IE divide 1 plus beta. In here, they calculate IB equal IE divide beta. The thing is they said IB too small. So that's why they supposed to be IE and IC the same. Okay? Then that they substitute, they calculate I in base equal. Okay? Finally, this is I in base. That's only thing you need to know. R in base equal beta times R prime E. About that thing, this means in here, they just prove it, okay? You don't have to get through that, but you need to know R in base equal beta times R prime E. If you want to learn more, then you have to keep reading in this thing.
So that means there are two formulas to find out R in base. One in terms of voltage over current, VB or IB, very first formula.
The first formula is just the basic.
Okay.
The first
So if we are
formula here, okay? VB divide IB. And they already tell you what VB equal. VB means from here to the route. So basically they will be equal IE times R prime E. It's easy to see on the schematic. Okay, you want to calculate the voltage from here to here. Then you take the current times resistor Ohm law. And they try substitute into that, and finally you get R in base equal beta times R prime E.
And VE here is 0 because the emitter is shorted to ground with a coupling or with a capacitor, correct?
Exactly.
With your bypass capacitor.
Exactly. AC, you don't have a R big E.
Okay, thank you.
Yeah, that look like you can get a little here. Okay, any question on that thing here? Very good if you're able to understand. You can go to college, university, no big deal. Okay, go. Now they're talking about voltage gain. Normally for the transistor amplifier, voltage gain will be equal V out divided to V in. Okay, however, if you're looking into the circuitry here, This is what they call a VC right here. VC. Okay. And that's what they call a VB. Okay. So the gain, that means the ratio between V out and V in. So that's why they get VC over VB. Okay. Now, how do we calculate the VC in this case or V out? You know the current flowing here is,
The current of RC times RC.
yeah, that's the current right here. Okay. IC. Okay. Basically, they will be IC. Okay. And the current flow here. What current?
IE.
IE. Perfect. IE. Current here will be IC. Okay. And now, if you want to calculate the VC, they can take the VC IC time
RC.
IC. In this example here, they're using IE. Why? The thing is they support IE and IC the same. Okay? And if you want to calculate the VB from here to the route will be IE times R prime E. Okay? And then they substitute IE times RC, IE times R prime E. Finally, this is the formula for calculate the gain. So if you want to calculate the gain, then you take the VC divide to R prime E. Now I make a little change, okay, on this circuitry here. Okay, on this circuitry here. Can you tell me what the, let's see, try to get adding pay. On this circuitry, I want to know what the G out. Okay, some books say G out, some books say load. Doesn't matter. That means they're talking about the resistor looking into output. In this case, what the L equal?
RL.
We're talking about AC, okay? Who knows telling me? So if I draw
It
it,
is,
you
I
can
think
make
it's
it
the square root of RL plus
Parallel R1, parallel R2, and parallel RL.
Hello, you're looking at the output, not input. I want to show that the input.
ZR with the RC parallel RL.
Perfect. Now, That's what I try to draw for you. Okay, that's the collector, you get RC. However, RC now go this way. Why? The thing is this power will be connected to ground in AC. That means in the collector here, you get one RC connect to ground, and also you get another one. That will be when you're looking into that. So basically our load now will be RC parallel RL.
I'm sorry, Mr. Pham, can you explain to me again why did we connect the VCC to ground for the AC signal?
I already said at the beginning, you want to converting circuitry to the AC. First thing, you cannot see any more capacitor. It's shorted. Second thing, you cannot see any DC voltage. They must be grounded. That is the rules, the law. You have to follow it.
Okay, thank you.
Okay. So when you connect the VCC to ground, so basically at the collector, you get a RC connect to collector and connect to ground. Same thing. RL connect to collector, connect to ground. So that's why they parallel. And when you're looking into the output of the amplifier, you get two resistors in parallel RCIL. So the output DL, in this case, they will be equal RC parallel IL. And that they will be calculated by RC times IL, divide RC plus IL. Now, in case they say the load only RC here, they don't telling you RL. That means they not using the load. Okay? If they not using the load, so output impedance only one RC.
Mr. Pham, is the reason that the VCC has to be grounded when you're measuring for AC, is it because the DC signal is too big and you won't be able to see the AC?
No. That is you're talking about for when you try to measure with the oscilloscope.
Yes.
On the VC, you get a 2 voltage, one AC and one DC. So that's why you have to know how to set up your scope to AC coupling or DC coupling. The reason is, I can tell you, at the at the bed right here, I given you example. You get 6.5 volt DC. Also, you can get the sideways. Okay, 500 millivolt pitch to pitch. So if you set your scope to the DC, you cannot see this guy, cannot see the AC sideways. The thing is that voltage is too small. If you're looking at the collector, you can see scope here, 0 volt right here, and you get 6.5 volt up here. And now the sine wave 500, they will be here.
Right. Okay.
So that's why if you not set to AC coupling, you cannot see the thing is 500 millivolt compared to 6.5 volt. They too small. Nowhere you can measure. Okay, that is you set a scope to DC coupling. DC coupling. What happens if you want to set to AC coupling? Okay. When you set the AC coupling, the scope will be just removed. This guy. And now they did the 500 millivolt peak to peak. That's why you're able to measure.
Thank you.
That's a key point for engineer technician. They must be understand that. Okay. Otherwise, you cannot measure the signal. Okay. Once again here, we already done. Okay, let's see, what else? Now, go to common collector. That one will be more easier. And the other also. Okay, when you're looking into the circuitry, recognize common collector. Input apply to the base. Right here. Output from ammeter. Okay. So that's why they get another name. A ammeter follower. Okay. What that means, ammeter follower? That's only telling you output following the ammeter. Ammeter signal, output signal will be the same. The thing is AC capacitor C2 will be shorted. Okay. That's the only thing you must be memorized. Input go to the base. Output from ammeter. Okay. And also they telling you input output will be in phase. You can see this one and the output here, same thing. Both going up, both going down. Okay. And now input impedance are in base, looking from here into the circuit. Okay. Out will be looking from output here to the circuitry. Okay. Anything you want to know more, just stop me. Now, I draw this one. Go to the AC. So go to the AC, you can see this part here. That's a transistor in AC. And you understand at the collector now they drowned it, right? So that's why they call common Common collector mean AC collector will be round. Common emitter, that means in AC emitter will be rounded. Common base, same thing, base will be rounded in AC. Okay, and they telling you this parking here. Okay, this is a transistor. This is the base right here, and also at the emitter you get the R big E, and also you can get another R load. Okay, so now if you're looking for output impedance, that means you're looking from here into the output of the amplifier. What output impedance equal? If you're looking here, you need to track it.
Voltage divider formula on RE and RL?
Exactly. That means you're looking this way. You can see RE, RL parallel. That's what output impedance. So in here, they do calculation for you. They get the output impedance they're using R small e. Okay, normally you can see they using the lower case for AC, upper case for DC. So R small e equal R big E parallel with RL. Okay, that's what we say right here. G out or R big R small e equal R big E parallel RL. That's output impedance. Now, input impedance. That means if you're looking from here into the transistor, how much resistance you can see. If you're following what they doing calculation here. Okay. So by finally R in base, okay, they will be equal beta times R small e. Okay. And then the formula to doing calculation. Then input impedance will be equal R1 parallel R2 parallel R in base. However, R in base will be calculated by beta times R small e. And then if you want to calculate them, gain, you know the V out. V out means right here. They will be IE times R small e. This will be IE here, times R small e. V in will be in IE. However, they will be times okay, they will be times with R prime E plus R small e. That's what I given to you here. Okay, so you take the voltage gain, you take V out divide to V in. Okay, IE they will be cancelled out. So you can get only R small e divide to R prime E plus R small e. That will be try to answer for some student asking how come you get this formula. If you want to get a formula here, You have to go from V out equal and V in equal. Okay, any question? It's hard, right?
Mr. Pham, I have a question. At the beginning, you said this kind of amplifier, the gain is close to 1. That means there is no amplifications. The input is almost equal in the output. So what is the application for this kind of amplifier?
You mean, okay, your question is how come one application like CC, the gain almost equal 1, right?
Yes,
How come we need that, right?
correct.
Okay, the reason is they get either high input impedance or high output impedance. They need. That means they don't want any more gain, but they want the output, the impedance must be changing. So they can using that. Normally
Okay.
amplified, you can get a different bigger gain. However, you understand on the AC, they transmitted, the matching impedance will be a very important. So that's why you can see your TV, okay, on your speaker, what the impedance. They can be 10 ohm, 8 ohm, 5 ohm, or TV maybe 75. Okay, that means amplify output, they have to get the same impedance to get the maximum power. Okay, so amplify here, one they want more impedance, and one they want more gain, they using CE amplify. If they just using for impedance, then they can using CC. They don't change anything, but they will be change input output impedance.
Okay, thank you so much. And is
Yeah.
that what they call it, buffering?
Yeah, look like same thing.
Perfect. Thank you so much.
Then they don't need the gain, but they need the impedance. Okay, the last one. We don't know. We don't need to go too much, but that one I want you next time I given you the circuitry, you can tell me the name. That's the key point. The name of the amplifier. Second thing, input output, how they look. Okay, in phase or out of phase. CB amplified, input applied to the ammeter. You see that input here, applied to the ammeter. Output from the collector. Okay, that's what we call a common base. What is the name for C2 here?
Bypass.
Ah,
Bypass.
do not say I say anything that means look like they're not correct.
Coupling?
DC blocking.
They say blocking. Okay, now I asking you one thing. If the capacitor C2 short, what happened?
Base is 0.
So the
VC
voltage at the base, no matter DC, AC, they will be here.
0.
Zero, they short to the right. If you don't have a DC voltage here, transistor not working, right? So this capacitor must be a DC blocking. That means for DC, they open. That's why voltage at the base not go to the right. However, for AC, they just like the wire. They short the base to the right. thing is normally for interview, they just asking you very general question. To asking for knowledge, understanding. They're not trying to asking you what is the formula to calculate the gain. No, who cares? Okay. Normally they can asking you how can you calculate the VDC at the base. You have to say just using the voltage divider. A very, very simple question. To make sure you study. Okay. What else on this slide here? Okay. This is, I put a wrong page. That's okay. This is they just given you. Okay. The formula how to calculate the gain. Okay. Finally, this is what you need. AV equal RC over R prime E. Okay. And also in here, I given you input resistance. Okay. R in resistance will be equal here. No more. Okay. Now, make sure you guys will be download assignment 19. I will be helping you to do e-calculation CC amplifier. The thing is we have to using the calculation program a lot. So there have to be no problem. Okay. Make sure you download that for me. Anyone need any question, anything you want to ask? Maybe Sam can help for a few minutes.
Okay, so the floor is open. Bring it on, folks. Come on, Catherine, you got a few. Wendell, don't be shy now.
Yeah, anything you don't know, that is a very good chance to try to learn. The thing is we will be get back into the lab very soon, and that will be not much time on the Zoom.
I think I read some stuff that made me more confused than I was before.
On what subject?
About beta versus alpha.
Oh, yeah.
That's for AC versus like somebody was talking about, okay, if you're doing the current gain, then you're calculating from collector to emitter as the inputs and outputs.
Yes.
And then when it's voltage, you're doing at the base and AC out. Is that correct?
Yes.
Oh, okay. All right. Thank you.
Yeah, you got it.
I have a question. This is
Okay.
Marcelo.
Okay, go ahead.
Could you please provide more details or the context why it's important the characterization of the impedance on these amplifier circuits? I think I didn't get the main idea why it's important to characterize the impedance of these circuits.
Okay,
Well,
that's it. Okay, you understand impedance, right? Input impedance, output impedance.
Yep.
Basically, the transmitter must be matching impedance. Okay?
Okay.
If they're not matching, you will be losing the signal. So that's why the input impedance, output impedance of the amplifier very important.
Okay, got it. So basically, the mismatch of impedance between the input and the output, it's going to jeopardize the amplification itself.
Right.
Okay, okay. Thank you, Mr. Pham.
Mr. Pham, the impedance, some people understand it like with the car stereos. If you don't match your impedance, if you got an amplifier in your car and you want to hook up speakers or hook the amplifier up to your radio puts out a signal at one size and the amplifier has an input signal at a different size. So you got to match that they must match in order to, that's a practical application. So I think if you talk about one of the practical applications like that, people might kind of get it.
Yeah, you understand the impedance important, like, you know, TV, every TV must be get the same input impedance. If mismatching, that the signal is not good. Or in the stereo, the voice get not right one.
Hey, like that gentleman was saying, so on your little board, I don't know if that was window or not, but like on your board, can you like make an example or show us an example? So that's something maybe I think I could stand to learn. Mr. Pham?
No. Only thing I can tell you, mismatch impedance, you're losing the power.
Can you draw like a little example or something on your pad?
Okay. If you guys want that, let's see how I just turn. Okay, I have to turn on my iPad.
Yeah, just use the car stereo example.
No, I don't know anything about that thing, but I can tell you.
Okay.
How come they not mismatching? Then they losing power.
Hey, thanks for answering that window. I could stand to learn that.
Yeah, that's what it's really all about. So, you know, if you got an amplifier and you got a radio, if the impedances don't match, you know, your radio can be putting out a signal too high for the amplifier.
That's what you have to know. Your stereo output, what impedance.
So when you go buy that stuff, you have to make sure that the output from your radio matches the input to the amplifier before it goes into your speaker. And then the output from your amplifier into your speakers have to match. So the input gain, the input to the output of the amplifier. So your radio gives an output. And so your radio has to be a low enough impedance to go into the amp. And so those two have to match. The output of the radio to the input of the amp have to match. It can't be too high. The output of the radio can't be higher than the input to the amp. And then when it goes through the amplifier and gets amplified, when it comes out of the amplifier, it's ready to go into your speaker. So the output from your amplifier have to match your speakers and amplifier. The output of the amplifier have to match the input to your speakers in order for you to hear it on your speakers. If there is a mismatch somewhere, you're going to have problems. It's not going to work. And so the inputs and outputs have to be matched. If it's a low impedance output from the radio, it has to be a low impedance input on the amplifier. And once it come out of the amplifier, the signal has been amplified. So it's a higher output. And so going into your speakers, you got to buy speakers to match the output of the amplifier in order to hear it in your car. That makes sense?
I hope that's on the recorder. You did a good job, man, but you're more ahead of this than some of us.
Okay,
Yes,
now
it was okay.
for 3 circuitry, I want to calculate the power. Number 1, P equal, okay, what? I square, right?
I squared R.
Time R. Okay, so number 1, what P equal? What current I?
I is 10 volts divided by
100 millivolts, or I'm sorry, 100 milliamps, excuse me.
10 divide 150, right?
150, correct. Total resistance.
Okay. So 10 divide 150.
Somebody got a calculator that can tell them what that is?
0.06.
10 divided by 150, where's the other 50?
He's got 2 resistors. He's got 2 resistors.
Oh, I'm sorry. I see now. My bad. I got it.
$0.066, right?
Yes.
And what power?
Power is I squared R.
I squared.
I squared times 100.
I squared. So this will be square. Is it 4.4?
0.4, right? I got
4.4.
0.3.4.
I get 4.4. I 0.066 square.
0.44.
Oh, okay. I try again. Oh, okay. Let's see. They divide by what you get. Just tell me.
0.044.
Okay.
0.044.
0.04. That's okay.
No, it's I'm
No,
sorry, Mr. Fan.
0.44.
It's
0.44.
correction. It's 0.44 watt.
You say wrong, right?
Yes, the answer is 0.44 watt.
Okay. 0.44 what?
Okay.
That's the first one. Second one. You
Second one.
calculate
1 watt is the power.
what you get.
1 watt even.
No, that's half a watt.
Huh. So basically, you can calculate I equal 10 divide 90.
No, that one. Okay, so that one is the
Oh,
It's
I was doing the wrong
0.1. 0.11.
0.11. And now P2.
so P2 it's 0.49.
0.49.
0.49.
So what you get?
0.49 watt.
0.49 watt. Okay, last one, number 3. I equal 10 divide 100.
0.1.
0.1, right?
Yes.
What P3?
0.5.
0.5 watt.
Okay, now compare. Which one is the best?
The third one. The third circuit.
The third one. You can say this is they not meet matching. They not matching. This one also they not matching. This one 50-50. They matching. So the power will be maximum. Let's just bring it up for you. For the transmission, okay? The impedance must be matching in order for maximum power. So if you get your stereo amplifier and you connect to the speaker, then you have to know what the output of your amplifier impedance. And they will be input into the speaker. They be matching in order to get the maximum power.
That's it.
Yeah, any question?
This is a very good example. Thank you, Mr. Pham.
Yeah, thank
Yeah,
you.
if anybody need a stereo hookup or anything, we'll contact Wendell Weber.
Mr. Pham, I just want to
All right, I'll be
double
waiting
check
on
my
you.
own bad math if I can. So in this case, would the power formula voltage times current does not apply?
What do you mean, for high current or what?
So you're using current squared times resistance to find the power, right?
Right,
I also have a power formula that's just voltage times current.
VI.
Correct, but that's giving me a different answer than that.
Depending on what voltage you look at.
You're looking into the power of the load.
Times that, and that'll give
You're using VI, then you have to know what V around across the load, not using 10.
I see. Okay, that's where I'm making my mistake. Okay. Thank you very much then.
Yeah. Your guy is still young. You have to be smarter than myself. I'm older.
Hey, Mr. Pham, I understand, like, for you or Wendell, whatever, RL is the load. Well, what is RS in this? What role does RS play in
That
this?
means the internal output resistance of the amplifier or the generator, anything.
Oh, so RS is the amplifier or something else?
Yeah, that means if you're looking into your amplifier on the car, what the output impedance, that means RS.
Okay.
When you're looking into the generator, what output impedance, normally you can see 50 ohm, right?
Okay.
That's the output impedance of the generator.
So
That's
that
just
would,
the
that would
natural
be
impedance of the components.
That's the That's the impedance of the machine.
So RS represents the output of the amplifier or the regulator or whatever you're using.
Whatever. When you connect to somewhere else.
And the somewhere else that you're talking about refers to
the load.
The load. Okay.
Right.
Hey, it might help you to understand that. Let's say with the oscilloscope, right? You're using the signal generator to create your sine wave. So the output from the signal generator would be RS, and when you touch onto the circuit card, the input of the circuit card, or that would be your input to your amplifier. So
that would be like the load.
Yeah, in that sense. In that sense, yes, that would be the impedance that you would have to match.
Okay, okay. So, and just let me jump in real quick. So RS is the output from the generator, and
yeah,
whatever you hook it to is RS.
No, what you hooking it to is the input of, so like on the circuit card to the amplifier. So where he's talking about the input to the base or the input to the emitter, wherever you put that input is into that circuit. So RS would be separate. It's not a part of your circuit. It's not a part of that amplifier circuit. RS would be the other instrument or the other device. Okay. But he's able to show it here mathematically how it works in a circuit, because once you connect it, RS, if you don't match it, like with
you're talking about that a different story. Okay, you're talking about when you connect the generator into the input of the circuitry, right?
Okay, yeah.
They don't care about the impedance. They care about
the signal.
They're not loading that signal from generator. So that's why if you say 5 volt peak to peak, you get 5 volt peak to peak. If they get only 2 volt peak to peak, that means your circuitry get a problem. They loading down the signal from generator.
Okay.
See that? The thing is, when they design the circuitry, they have to already know that.
Okay.
Make sure they cannot connect generator into that and the voltage generator going down. No. They don't have to be mismatching.
Okay.
Only thing, they're not loading down.
I stand corrected.
Okay, so any more questions?
Thank you.
No problem. Hopefully, every time we get through it, you can understand a little more. I believe not much, but have to get something done. Okay, so now quickly, we get not much time. We want to help you how to edit your calculation program. Okay, so the first thing is make sure you can get into generator. You can get into visual. Okay, you see visual now, right?
Yes.
Okay, so I will be quickly done. Okay, you go into new project. Okay. Also, I can tell you if you get any problem, you don't know how to do what to do, then you can get Zoom with me. I can help you out. Okay, nothing can be done without understanding. So you say you select Win32 and you can type in the name of your project here. Okay, any name. In this case will be a CB calculation CB amplified, but I don't care. Okay, and now also make sure you browse it here. That will be telling you where you want this project to be saved into your computer. Okay, if you know somewhere, then you just say select folder. Then you can say okay. However, before we move, normally I say copy the file name here, Control C. Okay, and you say okay. Okay, then you say night. Unlock that one. On that one. Marking on that one. And say finish. Okay, then a next step, right click on your project, add new item. And select C++ here. If you want the name for your project, you already copy, now you can paste them out. And you can say add. Okay, so basically now almost done. One more step, right click, property. And make sure you select common language, arrow here, /CLR, apply. Okay. So now you're ready to edit it. However, normally do not try to type in everything. We don't want that. We need to open one project, C++ already done. Copy. Okay. Then I go into my. Okay, I can go to my in here. I'm trying to looking for the project somewhere. Take one, calculation here, program here, and I can take the CE or CC or whatever, CC here. Okay, I give it to you at rank one. You see, in here you get a common collector. Two, okay, folder. Click on the second one. And you see in here they get a C++ short file. And you can click on that. Okay. You see that? They will be displayed here. Okay, now in here you can get two, project here. One in the you just open, and this one is the your new. So basically you want to copy everything. In order to do it, what you do? Control
Control A.
Control A, right? Okay, then Control
C.
C. Okay, now you exit this guy. We don't need anymore. Okay, then Control V. Okay, so basically, I will be delete everything. Keep only one test. Test number 1. Okay, from here going down, delete that. Okay, no more. Okay, so you get only one. Now, first thing, project name here, you change to the what they wanted. E-calculation CCMD5. This same thing. Programmer your name. What the version date. What day you do it. Okay, and this one nothing change. That's what you need to do. Okay, you have to change anything we need. That means you need to make a decoration. Now, if you're looking on your schematic here, okay, so they already telling you they want R1, R2, RE, RL, VCC, beta, VBE, and VE. Okay, then you can apply typing in here. Remember, in the schematic, they say 10, 18 kilo ohm. However, you define must be in ohm. Okay, computer don't know K. So that's why 18K, that's what we get a comment here telling you 18K times 1,000 get 18,000 and 18,000, 1,000, so forth. Okay.
Hey, Mr. Pham, a question.
Yeah.
Because I know we did some of this last time in the summer, but everything that's on the schematic, that's the stuff that we want to be putting like double and then put it in the declaration or whatever. But if it's not on there, don't put it on there. Because as we found out in the past, there are ways where people can make it pass by putting extra stuff on that is not on the circuit itself.
No, that it must be following the circuit.
Right.
If you change it, you try to cheating, then Sam will be put it fail right away.
It's not about just saying pass. Sam's actually going to look over your programming.
No, Sam will be looked over. Okay, this cannot be changed.
Right.
Now,
only the stuff that's on the schematic itself.
right. Now, this one here, you don't have to do anything. Make sure keep same thing. Only version date. That means the day you do it, you can change. Okay, for CMeter, take one. The name in here you must be changing. Okay, I don't want to get the credit.
So I can't use Mr. Pham?
Okay, and this one you will be changed to the name of your project, like e-calculation CCMD5.
Okay.
Okay, only thing you will be doing will be from here. That one from here. That's number one. Now, first thing I can tell you, you go into your Excel. That number one, copy. Highlight that one. You see that? Copy it. Control C. Okay. And now you can go into your, okay, that number one here. So that number one, you can, whatever they get, just paste them out. Okay. So now in that comment here, telling you first title, calculate, then you can copy title here. Okay. Copy, Control C, paste you here. Control V. And now formula. You can say this is a VBB equal. That is a formula. VCC times R2. And now you paste to the formula. Okay. Expect value 4.79 times 4.79. Unit VDC. Okay. And now double here. Then basically you copy your formula. Okay. Let's see why we don't have a that one. Let's see. Copy. Okay. That is your formula. So now you can copy that formula. Copy, paste into here. V. Okay, and make sure they have to be VBB. That means you're done for the first one. You want to do for the second one. I just do a second one for you. Copy that number one. Control C. Control V. Change that number one to that number two. Okay. Then you go back to your Excel. Copy number two. Control C. Okay. Then now you can paste them out here. Control V. Okay. The title, copy title here. Control C. V. Okay. Formula. Right here. Copy. And that formula here. Expect value 4.11. Okay. And now you go to the double here, copy VE here. Paste them out here. Okay. And this must be changing to VE. Okay, now after you get to test, compile and run. Okay. Build. You can rebuild or build, doesn't matter. Okay, successful. Run. Debug. Quit down debugging. You see that? You get 2 tests and you run it. Pass. You adding another test. Run again. If it failed, then you can fix it right away. Don't try to add it 13 tests and compile and run. That give a lot of problem. We can do one by one. So this is not a big deal, just a formula. Okay. So anyone get anything, okay, you want to add.
Yeah, I have a question.
A lot of calculation we'll be doing. Yes, sir.
What happens if you get an error?
Then you have to fix the error.
Sometimes I don't understand what it means. I did one yesterday. I got an error. I wish if I wrote it down. I don't remember what it is, but I couldn't figure out what is the problem.
Okay. Now, first thing, when you think you get error and you don't know how to solve the problem, right? Just take to me. You can get Zoom with me just about 10 minutes.
Okay.
That will be help. Okay.
Okay.
The thing is, I can open that again. Okay. And I given you one example.
Thank you.
Yeah, no problem. Don't try something you don't know how to do. Okay. Just let me know and I help you out. Now I can open the one we already done. Okay. I can give you the error here. This test number 1. Okay. So if you get no semicolon, then when you combine it, rebuild. Okay, now they get an error. Okay, now you move to the red one, double click. They show you're doing something wrong in here.
Okay.
Okay, you see the error right here.
Yes.
That means they tell you something wrong. But the computer is stupid. You're wrong on the expect value here. You see that?
Okay.
Any statement must be end with semicolon. And you're missing semicolon here, so that's why error. However, they're supposed to show you on pin 39, but they're not. They show you on pin on like 40. Okay? So if you put a semicolon here, then you're okay. Okay? And also now I change something here. I put a comment here. Okay, now I will be run. If you're looking here, number 1 part, 2 part, but number 3 failed. Okay? When they fail number 3, you don't care what else here, doesn't matter to you. You have to fix at the number 3. Okay. Now, you know something wrong on that number 3. But I can tell you one thing. You want to calculate IE, you take a VE divide RE. That's correct. However, the value coming out of the IE must be ampere. Why? VE voltage divide RE will be in ohm. The value they must be ampere. However, they asking you for milliamp. That's why they fail. So you can see the line I put a comment here. That means I have to telling computer, okay, I want to send it to the milliamp. So IE will be equal IE times 1,000. That means I send it to the milliamp. That's what they wanted. Then they will be passed. Another thing, I can telling to see how many people can be following. That's what they call a debugger. Without this tool, it's hard to know how to working with the software. Now I set the break right here. You see, I set the red point right here. They're telling me when the computer runs to the line 62, they will be stopped. Okay, so I can investigate it. You can see, I go debug, start debugging. Okay, not debugger. I debugger. Okay, now you see that when I run up to here, they stop. So if you're looking into the display in here, they can telling you what the IE, what the VE, what they do the calculation. That means the value. Then you can find out, okay, look like this will be a ampere, not milliamp. So that's why you need to change it to the milliamp. Okay? When you're able to debug, then any problem will be easy to fix. But that's good enough for today. We will see you guys next week.
Thank you so much.
Okay, one moment. Let me go ahead and share this page with the student real quick.
Okay, no big deal.
Okay. All right. So they said they're asking, so do you upload the software into the website? Yes, you can, or you can also, once you have it, once you have your the C++ pass, you can copy the C++ and then you can pay, and then you can come into like I have here. I open up my the assignment 19 here. Okay, so this is the program that was supposed to be done for 19. Now I can open up another page here. I can click on this plus here. Now I already opened up and then I name it down here to C++ and I copy that program into here. Okay.
That's by far the best way to do it, Sam, because then you have the Excel sheet attached to it. You don't have it separate
and
place.
then I can flip back and forth to look at the two, the software that you have and that is based on this assignment. Okay, and then you paste it onto this page, and then upload this into the website. That is one way to do it. The other one, like Mr. Pham said, you can go open up from the file folder, and to look for the one with this Visual C++ and upload that into the website. Okay, but like Adam said, yeah, this is probably would be more ideal. So if you can download the the Excel. And then once you have your program working correctly, and then you want to do is copy the software there and paste it here on the next sheet. And so that way I can be able to take this information and take a look at the coding. Okay. So that's it.
It'll help you be able to go back and look at it and understand it a lot quicker and easier because you'll have the actual assignment attached to your programming. Whereas if you just have the programming, you have to have the assignment with it also.
Good point. Okay.
Thank you.
All right. Okay. Any other question?
Yes, I have a question.
Okay,
Is
go
there a
ahead.
place where we can get all the formulas on the website?
No, you want to do is keep track of all the formulas as we go through, as you go through it. Mainly when I went through it, when I do the assignment, I sort of draw, make the formula as I go.
Okay.
And so that way I can use that to study for my exam or use that to study before my job interview. Okay. All right. Any next question? Everyone's good? All right. We'll see you tomorrow.
Thank you.
You're welcome.
Thank you.
Thank
Have a
you.
good weekend.
Okay, bye-bye.
Bye-bye.
Thank you for